Hello, today we're going to go into a lesson which is using synthetic division. Now you might ask, what is synthetic division? I've never heard of that. Synthetic division is just another method for doing another method of doing division of polynomials. More specifically, if you have a polynomial divided by a binomial. So to start out, to divide a polynomial by another polynomial, you can use long division. We already know that. We have done that in this class. And we know that that process is similar to long division of numbers. So we're just going to do a quick little review problem of that. So if we're doing long division of polynomials, we would have 5x to the fourth minus 10x. Ooh, I need to be careful right away because I'm missing my cubed term, so I'm going to put in a plus 0x cubed minus 10x squared plus 3x minus 1. Now I need to put that 0x cubed in there as a placeholder. And then on the outside we'll have x squared plus 2x minus 3. So remember, when we're doing long division of polynomials, we have to start with our first two terms in the dividend and divisor, and we have to say, from x squared, what would I need to multiply by in order to get 5x to the fourth? And that would be, we would need to multiply by 5x squared. So we're going to put that above our squared terms. And then remember, I need to take that 5x squared and multiply it by each of those terms on the outside there, by the x squared, by the 2x, and by the negative 3. So I'll have 5x to the fourth. 5x squared times 2x gives me 10x cubed. And then 5x squared times negative 3 gives me negative 15x squared. And then, if you would remember, we also need to switch the signs of each of these terms down here because we're subtracting. So that turns into a minus, that turns into a minus, this turns into a plus. And then we subtract. 5x to the fourth minus 5x to the fourth is gone, it cancels out. 0x cubed minus 10x cubed, we would get a negative 10x cubed. Negative 10x squared plus 15x squared gives us a plus 5x squared. And then we need to drop down that plus 3x. And our process starts over again. So what we have to do from here is we have to say, what would I need to multiply x squared by in order to get a negative 10x cubed? So we'd be missing a negative 10x. So that's going to go above our x terms. From here, let's multiply again. So negative 10x squared times x, negative 10x times x squared gives us negative 10x cubed. Negative 10x times 2x gives us minus 20x squared. Negative 10x and negative 3 gives us positive 30x. And then remember, again, we need to switch the sign. So that's a minus, so it becomes a plus. That last one's a plus, so it becomes a minus. These cancel out. 5x squared plus 20x squared gives us 25x squared. 3x squared minus 30 gives us negative 27x. And then drop down that negative 1. Process starts over. The last term we're missing to go from x squared to 25x squared would be a 25, so plus 25. Again, let's move this over a little bit. Multiply that 25 by everything. So 25x squared, 25 times 2x gives us 50x, 25 times negative 3, negative 75. Switch the signs, minus, minus, plus. Those cancel out. We'll have negative 77x, and then plus 74. So because x squared doesn't go into that, this will be our remainder. So what that'll look like at the end, I'm just going to put a plus, and then negative 77x plus 74 all over x squared plus 2x minus 3. Okay, so this whole entire thing is our answer with that very big remainder. Now, this takes a long time to do, it's easy to make mistakes, and it's very tedious. Yes, if you get the steps down, it can be easy, but again, there's a lot of different spots where we can make mistakes. So there's got to be another way. And that other way that I'm going to show you today is using synthetic division. Okay, so when the divisor is a linear binomial of the form x minus k, you can use synthetic division. So that's our stipulation there. We have to be dividing by a linear binomial. You can use synthetic division. Synthetic division is an abbreviated form of long division in which only the coefficients are written. So we only need to be working with our coefficients. We don't need to worry about any of those x squareds, x to the fourths, anything like that. So this little box of synthetic division might not make sense, but it should once we go through an example or two. So one important thing to remember is, or to realize, since it's in the form of x minus k, because this is x plus 2, we actually have to use the opposite. So our divisor is going to be a negative 2, not a positive 2. So remember, we only have to deal with the coefficients and really the numbers for any of these. But we have to kind of flip what our divisor is, what number is in our divisor. So if that was a x minus 2, then we'd be using a positive. Now, what goes on the inside? We have a 3 that comes from here, negative 1, negative 10, and positive 11. Now, I'll go back now. So you can see that a just drops straight down. So the first term drops straight down, and then we multiply it by our divisor, by our k value. And then you add those two things together and just drop them down, and you just repeat that action over and over. So once you get it, it happens, it goes really fast. So we drop down our 3, multiply by negative 2, so we get negative 6. Negative 1 plus negative 6 is negative 7. Multiply by negative 2, we get a positive 14. Negative 10 plus 14 gives us a 4. Multiply by negative 2, we get negative 8. And then lastly, 11 minus 8, or negative 8 plus 11 gives us a 3. So the way that this works out for us, because we're dividing simply by a linear binomial, and our highest power on that inside would have been an x cubed, we just drop down to the next power. So everything loses an x. So our answer is going to be 3x squared minus 7x plus 4, and then our remainder is plus 3 over x plus 2. Okay? Let's move on to the next concept. The next little piece here is the remainder theorem. So if a polynomial f of x is divided by x minus k using synthetic division, the remainder is r equals f of k. So what that means is, by the remainder theorem, what it says in the next little piece, you can divide f of x by x minus k to find f of k. If synthetic division is used to divide, this process is called synthetic substitution. So what does this mean? So when we plug in a number k into a function, our remainder ends up being that actual k value. So let's try that out. In this example, I want you to look up here and notice we're missing an x squared. So I'm going to have to put in a placeholder just like I would with long division. And since they give us f of 5, I put a 5 out here. I don't have to flip that. So my numbers, we're going to have negative 2, 6, 0 for the placeholder, 15, and negative 1. Drop this down, negative 2 times 5, negative 10. Add those together, negative 4 times 5, negative 20. Add those together, negative 20 times 5, negative 100. Add those together, negative 85 times 5 is negative 425, I believe. And then add those together, we get negative 426. Okay, so what the remainder theorem is saying is I can use synthetic division. This highest power is x to the fourth, so this would be x cubed, x squared, x, our constant, and then our remainder. So they're saying that negative 426 is our remainder. They're also saying that if I plugged in a 5 into each of those x's in my original function, then I would get negative 426. And you guys can check that, and that is true. Okay, let's just do one more example, a little more applied to life type of thing. Based on the U.S. Census results for the years of 1950 through 2000, the population of Nevada can be modeled by the function p of x equals 12x cubed minus 16x squared plus 150x plus 154, where x is the number of decades since 1950 and p of x is the population in thousands. So we want to use p of x to predict the population in the year 2010. So up to 2000 using, if that's going to be our function, and we're looking at decades, 2010 is going to be 6 decades away. So we can either plug in a 6 into each of those values and evaluate, or we can use synthetic substitution or along with the remainder theorem. So this is going to be a 6 on the outside, and we put in our values, 12, negative 16, 150, and 154. And then we do synthetic division. So this will be 72. Oh, jump of the gun. This will be a 12 times 6 is 72. Minus 16 gives us 56. 56, that'd be 336. Add those together and we get 486. Now I'm going to have to use some longhand. 486 times 6, we get a 36. 48 plus 3, and 29. 2916. Let's add 154. So 0, 1, 7, 0, 3. All right, so our population, since that's population in thousands, we could add 3 zeros onto there, and that population in 2010 would be 3,070,000 people, to put that in a context, the way that population grows. So that's all I have for you guys for synthetic division. I hope that it was beneficial to you, and I hope you have a great day.